So, we are back, Algebra 1. Today's date is Tuesday, September 24th, 2019. So there it is, 9/24/19. Number of solutions. Who wants to read the objective with quiet raised hand with their card? Looks like Hazi has his card.
Determine whether an equation has no solutions, one solution, or infinite solutions.
Loud and proud, I love it. Thank you, Hazi. Yes, so you guys have only been dealing with this one so far. One solution. Question?
Are all these answers correct?
Oh, I might have made a mistake. If there's a mistake, that's a teacher error. So,
If they're all supposed to be correct, I was just wondering if you're finding or not.
okay, example 1, 2, and 3 should be correct. So what we've been doing so far in class is this. We have been finding one solution over and over and over again. Question? Emma? Okay. We've been finding one solution over and over again, and now I'm going to show you what happens when we have no solutions, or what happens when we have an infinite amount of solutions. And you need to be able to tell me by the end of class, not what the answer is, but if it's one solution, no solutions, or infinite solutions. I don't even care if the answer was x equals 2 or x equals -2 in this case. I care whether there's one solution, no solutions, or infinite solutions. All right, so let's begin the notes. So after solving, you get a form similar to what, and you'll get one solution. And the answer here is your variable is equal to a number. So an example would be something like x equals 1. X equals 0, y equals -2, z is equal to 7/3. These are all examples when you get one solution. You see a variable is equal to one number. This is the default. This is what we're used to. The whole past month we've been dealing with equations where we get some answer like this at the very end. I'm just making those up. You could have made up a random number. Just make a letter, a variable, set it equal to a number, boom, you get one solution. One solution. Yeah, Eamon?
An infinite solution would be an answer in which it's not straightforward. It can be pretty much anything like two equal numbers.
Cool. Like, what would you mean by two equal numbers?
Like, I'm just using placeholder variables for this one. A equals A.
Yeah, so that would be an example that I could do. So let's all write it down. A equals A. That would be something that would give you infinite solutions. Anything where the left is equal to the right, that is always going to give you infinite solutions. So if I have 2 is equal to 2, 3x plus 1 is equal to 3x plus 1, anything where the left and right, as Eamon said, are equal to each other, that will always give you infinite solutions. So before we get to infinite solutions, though, let's talk about example 1. So this is an example that I just made up from the fly. I solved it. I hope there's no error. Let's go through this line by line, make sure I didn't do anything. I distributed the 2 into both of these. 2 times 3x is 6x. 2 times -7 is -14. So far, so good. Not changing the right-hand side. I'm going to subtract 3x from both sides. I get 3x minus 14 equals -20. I'm going to add 14 to get the constants on the right side. And it looks like I got 3x is equal to 6. And then I'm going to divide both sides by 3. And I get x is equal to -2. I think that's right. Let's go ahead and box it. That was the final answer. This is one solution because it matches this form of a variable is equal to a number. No questions so far. This is what we're used to. This is nice in review. The new stuff now comes when I have an infinite number of solutions. So the way that I think about this is I'm asking you, what is an answer? Could I have 2? Is 2 an answer? 2 is an answer. 3 is an answer. All of these things are possible answers. And I'll show you what I mean by that when we look at example 2.
Yeah.
So look at example 2. It's very similar to example 1. You have distribution on the left-hand side. We distributed the 2, and we got 6x minus 14. But the right side is also 6x minus 14. What's up, Charles?
Can you write in how we would get other answers?
If you want, yeah. The main thing to know here is you could have stopped right here. So I'm going to draw an arrow. You can stop right here. Can stop here. Because the left side and the right side are already equal to each other. We didn't even have to subtract 6x from both sides. It definitely makes it clear that -14 is equal to -14. But what this is saying is that I can choose any number that you want. Someone choose, well, let's do an easy number, a whole number.
Could we stop at the first part?
I mean, if you can just see ahead that this is equal to that, yeah, you're done. If you can see that far ahead, yeah, I totally agree. Someone choose a whole number. Some nice whole number. Shut up, Wyatt.
9.
9. Let's see what happens when we plug in 9. Theoretically, any number should work. Any number should work. So Wyatt, to get the full participation points, you're going to do this one. 9 times 3?
9 times 3 would then be 27.
27 minus 7?
20.
20. And 20 times 2?
40.
So that means you're saying if I plug in 9, the left side is 40. You don't have to write this down. I'm just showing you this as an example. And then again, 9 times 6, Wyatt?
54.
54 minus 14 is?
40.
Does 40 equal 40?
Yes.
Then it's true. 9 works. I can plug in any number. I can plug in 2/3. I can plug in pi. I can plug in e. Any number that you can think of, if I plug it in here, it will work. The answer is all answers. It's all solutions. There's an infinite number of solutions. If you don't believe me, try plugging in 0. If I plug in 0, it's 3 times 0 is 0, negative 7. Negative 7 times 2 is negative 14. And if I plug in 0 on the right-hand side, I also get negative 14. Any answer will work. All answers work. I'm going to write that down because I think that's kind of important. All answers work. You can choose any number for x, even if it's a fraction, even if it's a decimal, even if it's a transcendental number that repeats or never repeats and goes on forever and ever like pi. All of those numbers will work.
Wait, I thought pi was the only number.
No, there's an infinite number of numbers like that. Question, Asha.
So you're saying that like there's kind of not really a wrong answer here?
A wrong answer would be saying that there's only one answer. There are an infinite number of answers.
Oh, so what we're trying to do is like see if it is an infinite answer.
Yes, and it is. So whenever you have the same thing on the left and the same thing on the right, the answer is infinite. And if you all want to practice writing infinite, you can write it above the infinite. This is how you say infinite solutions. It's a sideways 8. If you guys take calculus, which I hope most of you will, you'll have to practice writing infinity lots and lots and lots.
Hey, infinity was a part of one of my fan characters, but then that was right.
Oh, okay. All right, so let's go on to no solutions. No solutions is when you have an impossibility, something that is mathematically never possible. An example of that would be something that says 1 equals 0. That never, ever, ever will happen. Eamon, question.
A does not equal B.
Well, if A and B, what if B was also equal to A? Like, what if A and B both had 7? So if you're dealing with variables, you might be careful with that. So if A was 7 and B was 7, then maybe A does equal B. But if you have a number equal to a different number, then definitely that's not true.
Wait, but A can't be equal to B because they're different variables.
You can have different variables set equal to each other. So if I have A equal to 7, B equal to 7, then you can say A does equal B.
So like they'd both be 7.
They would both be 7, yeah. So you can have two variables set equal to each other. So you have to be a little bit careful. But if you have numbers, strictly just numbers, okay, I'll just undo that. If I have strictly just numbers, that is definitely impossible. So choose two numbers for your example. Don't copy my example. Do your own two numbers. Set two numbers that are different equal to one another. -3 and 2/7. That's my example. That doesn't work because those are two different numbers. That is impossible. -3 does not equal 2/7. If you want to be cool, you can use some numbers that you haven't seen before. Phi is equal to E. That can't happen. Those are two different numbers. E is 2.7181828, whatever it is. And phi is... Wait, am I messing those up? I actually don't remember. You cannot have two numbers equal to each other. These are not variables. Maybe that will confuse us. Maybe I should have just done numbers. 3.14 cannot equal, or can equal 3. That does not work either. All right. So in example 3, it's again very similar to example 1. In example 1, I distributed on the left, and I got 6x minus 14 is equal to 6x minus 20. Well, I'm not sure. Maybe I will have one answer from here. So I did have to subtract 6x, and I got a number equal to another number. From here, there are no solutions. No matter what thing you put in for x, it will never, ever work. Kira?
Why? Like, what's a real life application for this?
Say you're working for the military and you need to shoot a missile out of there. Yeah? You need to know if it's possible to shoot that missile out of there. If you have an equation for your vector of your missile, and then you have another equation for so a missile is one equation, and then you shooting it out of the air is another equation. You need to know whether it's possible. Maybe there are multiple points where you will be able to intersect that missile. Maybe there are no answers for intersecting that missile. That's just one. I could give you like 3 more examples of trying to get solutions. Question, Esha.
Well, I have 2 questions. If I ask you a question, am I allowed to use my card or no?
I mean, if it's a really good question, I guess you can get your card. But usually I'm reserving that for answering questions.
Okay. Well, my question is, so when you do that, so you have 6x minus 14 equals 6x minus 20. So you subtract the 6x on both sides, and you just completely take those away, and then you just bring the stuff down, and that's how you get your answer. You don't have to do like what you usually do.
We are doing what we usually do, but there's nothing left to do, because if I'm trying to isolate the variable, let's ignore the right-hand side. Let's only look at the left-hand side. Let's move this variable, minus 6x. So minus 6x, minus 6x. Oh no, that killed the variable there and killed it there. There's no more variable. So it's just going from your natural orders or your natural operations that you would do, and then there's nothing else that you can do. You got negative 14 equals negative 20. It's the same operation you've been doing, except now we've ended with a number equal to a different number.
So basically, they're just canceling themselves out, and that's how you get the answer.
Yeah, exactly. What's your second question?
Oh no, my first question was left card. My second one was about that.
Got it. Okay. Yeah, and if you guys can try to find patterns and look ahead, if you have the same variable on the left and right, 6x and 6x, but these numbers are different, that should give you a clue as to what's happening. And then Charles had it from up here. If you have the exact same thing on the left and right, the same variable, but the same number and the same number, then that should give you a hint of what's going to happen. Of course, if you just do normal operations, you will still get there. So everything's the same. Keep solving these equations like normal, but now when you get your answer, maybe you get 2 different answers. Maybe you get a number equal to the same number or a number equal to a different number. It's the same thing, but just different answers, and that means that you have infinite solutions or no solutions. So we have example 4, 5, and 6. You are going to get one of each of them. So you guys are going to do these by yourselves. I'm not even going to do one of them with you. Try doing them by yourself. Simplify the left, simplify the right. You are going to tell me one solution, no solutions, or infinite solutions. It's one of those 3 possibilities. I don't want to know that x is equal to 2. I don't need to know that z is equal to 5. That would mean that there's one solution. Tell me if there's one solution, no solutions, or infinite solutions. Good luck.